Welcome everyone to my channel Space Remote Sensing and GIS, and today we will come with a very interesting lecture on how we will detect the ship over the SAR images. Okay, so that we will going to discuss. Okay, so for that I am just going to use a new tool in ArcGIS Pro, which is given here, okay, in ArcGIS 3.3, where you can directly extract the brightest points in the SAR data over the ocean. Okay, so let's see how we're going to do that. Okay, so for this I am just going to use a satellite image or high resolution satellite image of ICEYE, okay, GRD data product. So it's a very good high resolution satellite data which I am just going to use for this analysis. So the detect ship is a SAR image from the detect luminous ocean object tool, which is given newly in ArcGIS Pro. So how we are going to use that tool we are going to discuss in this exercise. Okay, so very first things, if you see here, I just open already a data which is here. Okay, so that is I see a data sets. Okay, so I'm just first I will open this data and I will show you how this data is actually, okay, so that you can understand. So I'm just opening this file. This is a raster product file, as you all know. So this is we call as a raster product file. So always we need to open the raster product file with this. So I'm just right click and add this. So let it is a big image of SAR, so it will take time to open. So once it is come, yeah, now it is came. So in this image we can very easily focus these areas. Okay, so you see it's looking little more brighter and so many noises we feel in the image. Okay, so this is SAR depicts of the Panama Canal areas, and it is a surrounding of that. So we are going to do the analysis over this data. Image which you seen here, it is a level 1 ground range detected. Okay, GRD data product of the SAR product from the satellite provider is ICEYE. Okay, so founder it is IC almost in 2014. So ICEYE is actually aimed to provide the reliable, timely informations about the planet Earth, okay, through the constellations of the small SAR satellites. Okay, so there are the satellites which is captured the high resolution images of the Earth surfaces, which is allow you for monitoring and analysis of the variety of the phenomena, including the natural disaster, environment changes, military applications, and so many infrastructure monitoring purposes we usually use these data sets. Okay, very first, if you see what I will going to do it over this, that is the radiometric calibrations. Okay, so that I will apply. So for that I need to go to the analysis toolbox. Under the toolbox you have, obviously you require the image analysis tool. Okay, so without that you can't do this. Okay, so image analysis tool extensions, under that Synthetic Aperture Radar. Okay, so here I'm going to do the first steps is the apply radiometric calibration process. So if I simply click on this apply radiometric calibration process, here I need to save these data sets. Okay, so I will just simply click over this scan data sets, and wherever you want to save this data, so you can save this. So few more things we have. This is a level 1 data which is contain the uncalibrated digital number as a pixels, but the calibrated process is converts in a DN value into the radar backscattering intensity value. Okay, which we are going to do it now. So backscattering intensity is actually a ratio of the emit signals, which is the incident of the surface to receive the signals. Okay, also it is known as a DN if reflects. So the radiometric brightness of the backscattering intensity can vary. Okay, so therefore the radiometric calibration is actually important to normalize these values and obtain the accurate quality, okay, quantitative observations for the quantitative measurements from the SAR data. So that's what we are actually doing here. Okay, and the next important thing is I'm just trying to calculate the gamma naught, not this beta naught, so I will change it to the gamma naught. And wherever you want to save your data, you can give this name something change and save it in that locations where you want to save this data. over here. Okay, sorry. Let's save it here. Okay, so I will give a name as a Panama SAR. So okay, sorry, it was caps on is Panama. Okay, so that's now given. Simply click on save. So first is radiometric calibrations which I am applying. So let's run over the image and you will see the noise will going to reduce in a very nice way. So let's run it and let's wait for the results. So now you see after I just run this applied radiometric collections, so image will be something looking like this. So what you need to do that you need to adjust this image so that you will get the image in a better way. So for that you have to change the symbology pattern. Okay, so how to open that? Simply click on this tab, so you can directly take it over there. Okay, if you want to give some proper color, okay, so that you can understand the high brightness value and the low brightness value over image. Okay, so in that case you need to change it. Okay, so this is already selected as a VV because of a single band only I used it here. Okay, so one thing you can do first is you just change this value 0.5 and the gamma value, just enter it, and you see if I increase the gamma value 2.0, okay, so my image will be much clear and I can highlight the bright values. So to highlight those ship values, okay, in the more high values, the brighter values are more high value as you see here. So you can select some kind of color pattern which will be helpful for you to identifying this these differences in a much more better way. Okay, so that's we try to understand. Let's see where is that. Yes, now we got this. So this is the riddle. Okay, so if I just change this value over this, now you see I can focus over the few areas which is already bookmarked. Okay, so I will just come to the map and I will select the bookmark areas. So if you see the northern eastern seas, okay, so you'll see all these bright values which is coming in a high value. Okay, so those are actually your what I said, that is the ship values which is we can simply understanding from this particular image. Okay, so similarly this is for the northern part. If you want to see the other part, okay, so I will just going to show you the southern part. Okay, so you will see this way how the ships are. Okay, and if I little zoomed over the ships so that you can understand, so it's not exactly the ship shapes, but it's like a star kind of twinkling kind of things which is coming. So the area which is high backscatter, which is appears as a yellow areas, which is the lower backscatter value, which is appear the indigo. Okay, shades. The oceans which appears mainly the indigo shades, as you see here. The land is appear mainly with the blue shades. Okay, and then oceans with ships which is appears as a yellow. So in this image I has backscatter value to type the scatter called, which is a double bounce in the types of the scattering, which is radar signals, which is actually reflect the vertical targets. Okay, by the times. So the smooth surface, which is before finally you can say returning the scenarios. Okay, so this is how it is coming. So now using this, if you want to extend the shape, so then there is a tool which you have to utilize. So before that you can save up to this whatever you did. Okay, and now if I want to move back, then simply right click and go to the zoom tool here, and there is a new tool which is introduced. So you come to the geoprocessing tools back here and see this tool. This is a detect bright ocean objects. Okay, so if you want to use this tool, okay, so to extracting that particular, this is known as detecting the luminous ocean object tools. Okay, so now ready for the final analysis. So here we will going to use the detect ship SAR. Okay, we are using the detect luminous ocean objects. So detect bright ocean objects. So that's here we are going to use this particular tools. okay, to extract the information. So take the 0 gamma on this calibrated SAR inputs, which I am going to use it here for look the pixels cluster, which is a high backscatter value, then luminous objects. If there is a filter them to retain the luminous objects of the you can say the specified the minimum maximum value, which I am going to do it now, and the results we will going to see the feature class which is showing as a rectangle boxes as a detect objects, which the results will come. So click on that. Okay, so input radar. So obviously you have to select the CRF values. Okay. Now before this I required one mask, because I don't want to consider this. I want to only consider this this much image. So this I will going to use as a mask for the next steps. Okay, and one more thing is required, that is a DEM. So the DEM is already I have, so I will add to the current map. So as you've seen here, if I switch off this one, so this is the DEM. So I will switch off this two actually. Now I will going to use this for the further steps. Okay, so further steps is detect bright object. Okay, so that only I will do. So I will select this image, input image of this SAR. Okay, Panama SAR dot CRF image, calibrated image, and now I am going to select the some value which I want to provide over here. So this I will provide here as suppose the 5 meter objects, the minimum size and maximum size, which is 500 meter. I think almost all the ships will come over this particular range. Then minimum value I will going to provide it here as a 10 meter, and the maximum value I will just going to provide here as a 700 meter. Okay, so if you see here now, that's what I select here. Now only I need to give the input of the DEM which I already open, so I will just select that. Okay, so here I will just click on this apply geoid corrections that I just need to open, and there is a mask tolerance. Okay, so first is the mask features. You can select this land polygons, and the feature types again select this land polygons. So then mask will be uploaded, means mask means this land polygon which I will put it as a mask. Okay, and the mask tolerance I am giving here, suppose has a 300 meter. So that's all for this upgradations. Okay, so now I will just going to play a run, okay, to see the results. Okay, so let's run. It will take a quite time, like 10 to 20 minutes time to get the results. So once I will get the results, I will going to show you what is the process, what is the results actually. So let's run and wait for the results. See, after run this process detect object, so I will get the results. Okay, so if you see here, if I zoom those areas where the ships is actually there. Okay, so you will see this is the northern sphere, and these are the ships which is very clearly visible. Okay, so I will just going to show you. Okay, so this I just need to go to show you this. Okay, so see here these are the ships which is detected, but there is a simply one shift you can observe. Okay, so it is not exactly, it will match with this. So for that you need to run one more process. Okay, so to adjust this, because I didn't do the geometric terrain corrections over this image. So if you do the geometric terrain corrections, okay, so you will get the results in a very nice way. So I will show you the process how we'll do that. So if you come to the toolbox, okay, under this again you have to go to the image analyst, Synthetic Aperture Radar, and here you have a tool that is called applied geometric terrain corrections. So this one. Okay, so for this you need to give the input of your SAR informations, that is Panama SAR radiometric corrected image. So terrain correct, this is the, I already actually run this process because all this process is taking so much time for run. So what is the image you need to run it over here, that is the CRF image. Okay, like calibrated image, that you need to give it here as an input. Okay, and here you can give a name of this as Panama terrain correction. Okay, so that you can give a name or by default whatever it is taking you can go for it. Okay, I'm not changing it, but the name we should be Panama terrain correction, which I already did, you just see here. Okay, so DEM, the same DEM you have to give as a reference. Okay, so once you give that, now your data is ready. So here you can just check on this applied geoid correction options. Okay, so that you need to do. Okay, so once you did this, okay, and then simply click on run. So once I will get run, I will get the results of this image. So I will show you now. This is the down image. Okay, so on the original image. So after the terrain corrections, the image you will get, that is this one, and you see now all the ships will come exactly with the boundary box. Okay, so that's the power of this particular tool. Okay, so which it is correcting the geometrically over this particular data and how it is going to represent it. So this is actually, I'm just giving thanks to Elizabeth from ISRI, so who is actually prepared this tutorial. Okay, so for the people who are, a lot of my followers who are actually watching my videos, so for them I just create this wonderful tutorial as a video format so that you can use these techniques. Okay, so this is what you have to do, then you will get this particular image over this. And she also did some analysis, just like the gridding system, like we already have some data sets it is providing you over here. Okay, so if you see under the input data, okay, so you will get some data sets. Okay, so those data sets you can use it for the grid. Suppose this is the 500 grid which I already will open over here. Okay, so this grid you need to overlay over this particular image first. Okay, and now see, I want to extract this using the summarize statistics tools, okay, to calculate the density of the ships. Okay, so how we going to do that? So that I just trying to explain. This is generate a ship density map, actually you can say. So if you see here, this is a 5 by 5 meter grid which we already created, which is covering the larger area. Okay, so here you come in the geos, and here you can type with a tool which is called summarize statistics. Okay, so summarize within, okay, analysis tool that you need to select. And this summarize within tool, you need to give the input of this grid data, okay, 5 kilometer grid, and the input features you can give the detected ships, whatever the ships you detected. So detect ships, that you can give as an input. Okay, and then this is a 5 kilometer summarize grid within one, so that I given a name, and I want to calculate it as a square meter, so I select it as a square meter. Okay, so that's all. So if you do this, then you will get the summaries statistics of the ships, where it is a high density, where it is a low density grid you will give it out. So if I click on the run, the results of this is you will get it, that is this one. Okay, so if I just put it over this, so this is how it is representing your data. So that I symbolize it actually. If I just go here and I symbolize it, okay, which is already I selected. Okay, so if you see here, this is the symbology which I fix it. This is the graduate color I applied over this points, and the field which is the count polygons, that you have to open. You see here, the count polygons is actually representing your ships. Okay, so the density it is actually mentioned accordingly. Okay, so if I give this color, so I will get the results, so which is clearly indicating that the area which is the high density showing the red area, and the areas which is the low density is showing as yellow. So it can be seen most of the ships will align to the northern and southern easterns of the canal, which is covering the approximately 75 square kilometer area of the engine. So this is what about this particular demonstrations. I hope you like these demonstrations. Okay, so if you like this video and this analysis, okay, so where we are actually trying to detect the ships. Okay, so please share this video with others, subscribe this channel, okay, and please give your comments. Thank you very much.